All right, 5.1, applying the primary trigonometric ratios. What we're looking at here, folks, is the concept of SOHCAHTOA. SOHCAHTOA is the acronym that we use to represent the primary trigonometric ratios. The first one, and we use the primary trigonometric ratios for right-angled triangles. The first one, SO, stands for sine of an angle, a specified angle, is equal to opposite over hypotenuse. And again, that angle that we're talking about is an angle between 0 and 90 degrees. So sine of an angle is equal to opposite over hypotenuse. Cosine of an angle theta is equal to adjacent over hypotenuse, and that represents the Ka part of SOHCAHTOA. TOA stands for tangent of an angle theta is equal to opposite over adjacent. Now, to understand opposite, hypotenuse, and adjacent, we need to look at a right angle triangle as such. Now, what's important to note is this right angle, this little square, always points to the hypotenuse. So the right angle points to the hypotenuse. So regardless of how this triangle is drawn, so just let me show you what I mean, is I can take this triangle and turn it. And by turning it, the hypotenuse changes, but it never leaves the side for which the right angle points to it. If you notice here, this right angle right here points to the hypotenuse. So that's really crucial that you remember that. So, when we look at this, we need to identify the angle first. So the angle that we're going to identify is this angle right here is known as an angle of elevation. We need to know the difference between an angle of elevation and an angle of depression, because an angle of elevation and an angle of depression have similar properties, meaning that an angle of elevation starts at the horizontal and points upwards as such. Another word for elevation is inclination. Now, if we have an angle of depression, again, that moves from a horizontal, just like the elevation, but to angle of depression is an angle that moves down from a horizontal. Now, the angle of depression or declination is known as the same values. So, for example, if someone is here at the bottom looking up towards someone here at the top of a hill, the person at the top of the hill will have the same angle of depression as the person at the bottom of the hill having an angle of elevation. In order to see each other, these angles will be the same value. And if you remember parallel line properties, you remember that there's something called the Z pattern. The Z pattern is the same. The angles on the alternating angles values are the same. Now, the other pieces we need to look at are, for example, the hypotenuse. The hypotenuse is the side that is opposite the right angle, just like I talked about earlier. Another thing to know is if this is the marked angle, looking here inside this triangle, the marked angle is right there in green, and I want to know which sides are opposite and adjacent. Well, the mark always touches two sides. The arc that marks the angle touches the hypotenuse, as you can see here, the hypotenuse here, and the adjacent, always. So if I was to mark, for example, this angle over here, the adjacent would change. This side would be the adjacent, and this side would be the hypotenuse. Remember, the hypotenuse is always defined by the right angle. But here, as we have it, this is the marked angle. The arc that marks the angle touches the adjacent and the hypotenuse, and the other side is the opposite side. All right, moving on to some examples. Example 1, solve the triangle. So if you're asked to solve a triangle, what that means is that you need to find all the angles and all the sides. So list all the angles and all the sides. And this is what we're doing. We're marking all the angles and all the sides, and we need to find the rest of the information. For example, we need to find angle A, angle C, and side A. All right, so we need to find one of the angles first. Let's start with angle C. We mark angle C with a mark, and we look at how to solve for C. Well, we have 8 and we have 17. 8 is the opposite side to C. 17 is touched by the mark. So the mark touches only the adjacent and the hypotenuse. Which side is 17? Well, if you look, the right angle points to 17, so that must be the hypotenuse. Now, let's think. What trig ratio represents opposite and hypotenuse? Hopefully, you're thinking so. So is represented by sine of angle C is equal to 8 over 17. C is equal to the sine inverse of 8 over 17. You type that into your calculator, folks, not 8 divided by 17, but sine inverse of 8 over 17, and that will equal 28.0725 degrees. And that's what we fill in for angle C. Next, we can find angle A, knowing that all three angles in a triangle add up to 180 degrees. So angle A is equal to 180 minus 90 minus 28.0725 degrees, which gives us 61.9275 degrees. And that's using sum angle triangle theorems, SATT for short, which represents all the angles in a triangle add up to 180 degrees. It's a theorem that we use. All right. Next thing we can use is Pythagorean Theorem to determine side A. This side is known as little a because it is opposite big A. So we need to find little a. Using Pythagorean Theorem, we find out that it's b squared, this side, the hypotenuse squared, equals the sum of the squares of the other two sides. So 17 squared is equal to a squared plus 8 squared. And this is equal to a squared turns out to be equal to 225, which means a is equal to 15. So a is equal to 15 centimeters, and angle A is equal to 61.9275 degrees. All right, one more. Given this question right here, a hot air balloon is flying at an altitude of 1,500 meters. The angle of depression from the balloon to a landmark on the ground is 34 degrees. What is the balloon's horizontal distance to the landmark to the nearest meter? What is the balloon's direct distance to the landmark to the nearest meter? So, let's look at this. There's a hot air balloon flying at an altitude of 1,500 meters. So that's at a right angle. It's altitude is measured at a right angle to the ground. Now there's some landmark over there. So let's say it's a statue. And that statue is the angle of depression to that statue is 34 degrees. Now, what we need to figure out is what is the horizontal distance to the landmark. That's this value right here. We also know that the angle of depression to the landmark is equal to the angle of elevation from the landmark to the balloon. So that will help us on the inside of this right angle triangle. Now we have opposite side is 1500, angle is here. We need to find this side, which is the adjacent. So we're actually going to use the tan ratio to figure out the first part, the answer to part A. Tan of 34 is equal to 1500 over adjacent. So what are we going to do now? We're going to either multiply or divide, and that's something we need to look at these values. How do we know when to multiply and how do we know when to divide? Well, folks, we're going to divide here because we don't know, the information we don't know is on the bottom. So if I was to move this adjacent to this side by multiplying, I would have to divide by tan 34. So it's going to equal 1500 over tan 34. And we just replace the word adjacent with the letter x to make it easier for us. So again, if the unknown is on the bottom, we divide. If the unknown is on the top, we multiply by the tan sine or cosine, whatever's on the other side. So here we're dividing by 1500 divided by tan 34, which will give us a value of 2,223.8415 meters. All right, next, we need to know the direct distance. That would be this value right here, the hypotenuse. So what ratio are we going to use? Well, we always use what's given, opposite, over the hypotenuse, which is what we're looking for. I recommend you use that because just in case you made a mistake on the adjacent, if you don't use this value again, then you don't have to worry about a mistake that you might have made. So sine 34 is equal to 1500 over the hypotenuse, which is now y. We're calling it y now. So y is equal to 1500 divided by sine 34. The reason why is on the bottom, so we need to divide. 1500 divided by sine 34 is equal to 2682.4375. So, therefore, the horizontal distance is 2224 meters, 2,224 meters, and the direct distance is 2,682 meters. The last thing we need to do is verify these values. For example, looking here, this is the hypotenuse. That value should be the highest number. And if we look at all the numbers we have here, it is. So it looks like our information is right. The other thing we can look at is 34 degrees is the smallest angle. It should be opposite the smallest side. And if you look carefully here, here's the smallest angle, 34. Opposite side is 1500, and 1500 compared to these other two values is the smallest side. So it looks like our information is correct. Alright folks, that's the end of the video. Have a numerical day.